Hello students, I hope you all are fine and you are keeping very good care of yourself. And in the previous section we have discussed the grouping of capacitors, isn't it? The capacitors can be grouped in either series way or in the parallel grouping, right? So today we will discuss using those concepts how to determine the charge and the potential difference across the plates of individual capacitors in case of mixed grouping of capacitors, right? So the most important concept before we start with the numericals, the most important concept to be remembered is that in the series grouping of capacitor, first point, the charge across the plates of each of the capacitors should be constant. Second, the potential difference across the plates of capacitors having different values of capacitances is different, right? While in the parallel grouping, the potential difference across the plates of each of the capacitors is same or constant, while the charge across the plates of capacitors having different value of capacitances would be different. And we are aware of the master formula, Q equals to CV. So using these 3-4 concepts, we can solve any question, right? Whether it is simple or complicated, you need to follow systematically. So let's start with a very, very simple question, right? Concentrate on the circuit diagram. We are taking a simple case and then we'll try to increase the level. Let us consider these are the 3 capacitors or condensers connected in mixed grouping like this. This point A, this point B. Let us consider these 2 points will be connected to a source which is giving a potential difference of 10 volt, right? And these are the capacitors C1, C2, C3. Suppose C1 is, let us consider it to be 4 microfarad. I have stated farad to be a large unit of capacitance. So normally the capacitance is expressed either in micro or in picofarad. C2 is suppose 2 microfarad and C3 is suppose, let us consider 3 microfarad, right? This is the simplest example. So this network is given to us, these values are also provided to us. What we are supposed to do is, we are supposed to calculate the charge and the potential difference across the plates of each of these 3 capacitors. So basically 6 results are to be obtained, right? We are basically supposed to find out the 6 results. So how to proceed? That's the most important part. How to proceed in dealing with such numericals? First step is to break the circuit, right? No shortcuts is to be used. Now these 2 are in parallel, there is no doubt regarding that. First and foremost, you need to proceed with those branches which we are very much aware of. There shouldn't be any sort of ambiguity. There is no doubt that these 2 are connected in parallel. Because if you indicate it as point C, then both these capacitors are connected between the same 2 points A and C. So these 2 capacitors must be connected in parallel. No doubt regarding that. So what is the resultant of these 2? Let it represent by C1. In the parallel combination, what is the result? It is given by C1 plus C2. So it will give us 6 microfarad. And this one is left, it is C3. It is 3 microfarad. This is point B and this is point C. Right? Proceed in this way. Then, this is suppose C123, the resultant capacitance of the entire given network, right? Obviously, these 2 are connected end to end, so they are connected in series. In the series grouping, the formula is 1 by C equals to 1 by C1 plus 1 by C2, or directly you can do C1 C2 divided by C1 plus C2. So over here, C123 it will be given by 6 into 3 divided by 6 plus 3. So 18 by 9, that is 2 microfarad. And students, always remember, in the series grouping, the resultant capacitance would be less than the minimum of the given value of capacitance. So before doing any sort of calculation, a rough idea should always be there at the back of your mind. What should be the range of the value? It should be obviously less than the minimum, less than 3, which is 2 microfarad. Right? So you can solve it. 1 by C 1, 2, 3. You can solve it like this. 1 by C 1, 2, 3. It will be equal to 1 by 6 plus 1 by 3. Solve it and taking reciprocal you should get 2 microfarad. So I recommend to do it directly. C1 C2 divided by C1 plus C2. So the net capacitance is 2 microfarad. And what about the net potential? It is 10. I hope these steps are pretty clear to you all. Right? So whenever some mixed grouping is given, and if you are supposed to find out the charge and the potential across the plates of each of the capacitors, the first step is to determine the net capacitance of the given network, following step by step. Clear? So net capacitance of this network is 2 microfarad. That's the resultant capacitance, right? Now using the concept. Now this is the master formula. You all are aware. Q equals to CV. This is the master formula. Out of these 3, if 2 are known to us, then the third one can easily be determined, isn't it? So here, look at this. Now we will follow the reverse step. Over here, net capacitance is 2 microfarad. Net potential is 10 volts, so we can easily find out the charge. So what about the net charge? Net charge 1, 2, 3. It will be equal to C into V net. That is 2 multiplied by 10. Isn't it? 2 microfarad multiplied by 10 is the potential. Q equals to CV. C is 2, V is 10. So it is 20. Don't forget to write the unit. Microcoulomb. Is it clear? The net charge on this plate of this capacitor would be 20 microcoulomb. We have calculated the value of net capacitance. The net potential across A and B is given. So the net charge can be easily found using this formula, C into V. So C is 2 microfarad, potential is 10. So 20 microcoulomb. Right? Now concept, reverse step. This one, C123, it is the series grouping of C12 and C3. I repeat, C123, it is the series grouping of C12 and C3. And in the series grouping, the charge across the plates of the capacitor must be constant. So we already calculated the charge over here, it is 20 microcoulomb. So it should also have Q12, it should also have charge of 20 microcoulomb and it should also have charge of 20 microcoulomb. Understood now? The charge across the plates of the capacitor, if they are connected in series, must be constant. That is what concept I have used over here. Now again, come to this. C12 is known, Q12 is known. So V12 can be easily calculated by using this formula. So V12, it would be equal to Q12 divided by C1. Let's check it out. It is 20 microcoulomb and C12 is 6 microfarad. So it will be 10 by 3 volt, or it is equal to 3.33 volt. So what is the potential difference across points A and C? 10 by 3 or 3.33 volt. Now what will be the potential difference across this? Q3 is known to us, C3 is known to us. So V3 can be calculated by using this Q3 by C3. Also, without doing this mathematical calculation, you can just make use of your common sense. The net PD between A and B is 10. Between A and C is 3.33. So this must be 10 minus 3.33. It should be 6.67. Let's calculate it. Q3, it's 20 microcoulomb. C3, it's 3 microfarad. So V3 is equal to 20 by 3 volt, which is equal to 6.67 volt. Isn't it? What is the addition of these two? 3.33 plus 6.67. That will give us 10 volt. In series, net potential difference is given by V equals to V1 plus V2 plus V3 and so on. I hope you are able to understand the concept. Right? So, now again, proceeding in the reverse direction. C12, it is the parallel grouping of C1 and C2. It's pretty clear. And students, in the parallel grouping, the potential difference across each plate of the capacitor is constant. Right? So, what is the potential difference across this? 10 by 3 volt or 3.33 volt. So, over here V2, it will be equal to 10 by 3 volt, and V1, it will be also equal to 10 by 3 volt. And between C and D, we have already calculated the potential is 20 by 3 volt, and the addition of V2 plus V3, that will give us 10 volt. Clear? So, the potential difference across C1 and C2 is same, each being equal to 10 by 3. Now, in order to find Q1, it will be equal to C1 V1. C1 is 4 microfarad. V1 is 10 by 3. So, it will be equal to 40 by 3 microcoulomb. This is the charge across the first capacitor. What about Q2? Q2 would be equal to C2 V2. We are aware of the value of C2, that is 2 microfarad. Micro I will write at the last, right? Into, what about V2? V2 is 10 by 3 again. So what about this? 20 by 3. C is in micro, so it will be in microcoulomb. This is Q2. So students, I think all the 6 results have been obtained, right? We have found Q1, we have found V1, we have found Q2, V2, and lastly we have found V3 as well as Q3. So all the 6 results have been obtained. So again, I must repeat, do such numericals step by step. There are no shortcuts basically. Keep practicing more and more numericals, and definitely you will attain that efficiency, right? So first step is to determine the equivalent capacitance of the given network by following step-by-step diagrams. And then use the concepts. In series grouping, the charge is constant. In parallel grouping, the potential difference is constant. In series, the formula of the resultant capacitance is 1 by C equals to 1 by C1 plus 1 by C2. In parallel, the resultant capacitance is C equals to C1 plus C2. And then make use of this basic formula and then follow in the reverse manner. You will get the result, right? So this was a very, very basic question. Now what we do is, we will discuss similar question. We will consider the grouping of maybe 4 condensers or 4 capacitors. And let's try to find out the charge and the potential across each capacitor. So let's consider this particular circuit diagram, right? Suppose this is a circuit diagram given. These are the 2 capacitors, maybe C1, C2. This is the 3rd capacitor, suppose it is C3. This is another capacitor, suppose this is C4. And these are the 2 points, A and B. Let us consider the potential difference between the points A and B is 300 volt. Let this be 100 microfarad, this be also 100 microfarad, let this be 200 microfarad, and let us consider this to be 100 microfarad. So students, considered on the circuit diagram, 4 capacitors C1, C2, C3, C4 are given, and they are connected across the points A and B as shown in the figure, and the net potential difference between these 2 points A and B is given to be 300 volt. Our objective is to determine the charge and the potential difference across each capacitor. So how many answers are we supposed to obtain? 8 answers, right? Charge and potential across the plates of each capacitor. So let's proceed. What's the first step? First step, as I told you, is to determine the equivalent capacitance between the 2 points across which the net potential is applied, right? So let's try to evaluate it. So what we'll do is, it can be modified. The circuit can be modified in this manner. If you stretch it like this, if you open the circuit like this, the diagram should be somewhat like this. So you need to simplify the diagram. You need to simplify the diagram. It should be somewhat like this. Check whether you are able to get yourself convinced or not. This is the branch having C3. This one, if you open the circuit like this is C4, right? And these are the two capacitors, C1 and C2. And what's the potential difference between the points A and B? It is 300 volt. Am I clear? I think it's perfectly okay. Just open the circuit like this and simplify it. So this is the first step. Clear? Now, it becomes quite simple. You have to proceed with C1, C2. There's no doubt that these two capacitors are connected in series. In series, the resultant capacitance decreases. In case both are of the same value, then the resultant series capacitance would be equal to half of the individual capacitance, right? For example, here it is 100, it is also 100 microfarad. So the series grouping would be 50. You can check it. 1 by 100 plus 1 by 100, and in the last step, don't forget to take the reciprocal. So it can be further modified as this point B, this is C4, this is C3, and this is point A, and it is 300 volt. So this is C3, and 1, 2, it can be written as C12. These two are in series, so I'll write it over here, C12. It will be equal to 1 by C1 plus 1 by C2. Both are of value 100 microfarad. So you can easily evaluate it. C1, C2 divided by C1 plus C2. 100 into 100 divided by 100 plus 100. So it will give you 50. Isn't it? So 50 microfarad. So students, you need not to do these calculations. You need to do it in your mind, right? So when, listen to me, that's an important result. When the two capacitors are connected in series and have the same value, then the result would be equal to half of the given value of capacitance. 100, 100, the series combination will be 50. That is what we are going to do over here, right? So it is 50 microfarad. C3 is 200 microfarad and C4 is 100 microfarad, right? This is the result which we have obtained. Now, moving further. Okay. Students, these two are in parallel. No doubt regarding this. Therefore, the circuit may further be simplified as this is C4, 100 microfarad, and this one would be the combination of C12 and 3, that is C123. These are in parallel. In parallel, the formula to be used is net would be equal to C1 plus C2 plus C3 and so on. So 200 plus 50, it will give us 250 microfarad. This is point B. Further, these two are in series. This is point B, this is point A. So resultant capacitance C1, 2, 3, 4. And the potential difference across them is given to be 300 volt. Okay, what's the resultant capacitance? They are in series. So what will be the formula? I'm doing it over here. It will be 250 into 100 divided by 250 plus 100. So 25000 divided by 350. This and this get cancelled. You can easily solve it. So this will be in microfarad, right? So it is, if you simplify it, so it will be 500 divided by 7, isn't it? So it is 500 by 7 microfarad. Just check this step. What we have done is, we have found the net equivalent capacitance of this combination between the points A and B. Just check it. First, you need to simplify. These two are in series, the resultant is considered. These two are in parallel, and lastly, these two are in series. So this is the equivalent resistance, equivalent capacitance of the given network, right? Now, as I have told you, in order to determine the charge and the potential difference across the plates of each capacitor, we need to follow the reverse step. Let's do it. Okay. Net capacitance is known, net potential is known, net charge can be easily calculated. By which formula? Q equals to CV. So what about the net charge? Let's calculate Q1234. It will be equal to C1234 multiplied by net potential difference. So it is 500 by 7 multiplied by 300. Right? So it will be equal to 150000 divided by 7 into 10 to the minus 6 coulomb, which will be in micro. Right? It is in micro coulomb. So we can easily solve it. It will be equal to 15 by 7 into 10 to the minus 2 coulomb. Right? This is the charge. This is the net charge. Now, let's follow the reverse step. Students, look, this is the series combination of these two. And as I have told you, in the series grouping of capacitors, the charge across the plates of each capacitor must be constant. So same charge should be across the plate of capacitor C4 as well as C123. So over here, Q4, it will be equal to 15 by 7 into 10 to the minus 2 coulomb, and Q123, it should be again 15 by 7 into 10 to the minus 2 coulomb. Right? Now consider capacitor C4. C4 is given, Q4 is given. V4 can be easily calculated. What about V4? It will be equal to Q4 divided by C4. Q4 is 15 by 7 into 10 to the minus 2 divided by C4, that is 100 microfarad. It will be equal to 100 into 10 to the minus 6, that will give us 10 to the minus 4. Right? So what you get is 15 by 7 multiplied by 10 to the 2. So 1500 divided by 7. 7 is 1410. Almost 214.3 volts. Approximately 214.3 volts. Right? So this is the potential difference across this. So we have obtained V4. Now how to get V123? Total PD across points A and B is 300 volt. And the potential difference across this plus this would be 300. So if we have determined the potential difference across this point, so across this capacitor it will be 300 minus 214.3. Isn't it? So we can also solve it. So if we wish to calculate V123, it will be equal to Q123 divided by C123. So that will give us Q123 is 15 by 7 into 10 to the minus 2. C123 is 250 micro 10 to the minus 6. So what you get is 15 by 7 into 250 into 10 to the power, I think it will be 4. Or we can solve it 15 over 7 into 25 into 10 to the power 3. So what you get is 3000 divided by 35. You can solve it. And you will get the answer to be 300 minus 214.3. I am very, very sure. Right? So if you solve it, 3035 to 6. Right? What will be the result? 65 or whatever. So actually you will get the result. You will get 80, in fact it should be 8. So 200. So it should be 3, or rather it should be 5. So 250.7. Okay, approximately it will be about 85.7 volt. Now look, if you add these two, you will get 300 volt. if you add these two, 214.3 plus 85.7 volt, you will get that value. Isn't it? So what we have obtained is, we have obtained Q4, we have obtained V4, we have obtained Q123, we have obtained V123. Right? Now again, proceeding in the reverse manner. Look, we have obtained V123, we have obtained V123. Now C123 is the parallel combination of C12 and C3. C123 is the parallel combination of C12 and C3. Therefore, in the parallel grouping, the potential difference must be constant. Here the potential difference is 85.7 volt. It is 85.7 volt. So across C3 and across C12, it should be having same value. So across this, it should be 85.7 volt. Across here also, it should be 85.7 volt. So we have found V3 as well. Now how to calculate Q3? Let's check it out. Q3 can be calculated again by using the same basic formula, Q equals to CV. Out of 3 variables, if the 2 are known, then the third can be easily calculated by using this formula, Q equals to CV. Now look, C3 is known to us, V3 is known to us. So Q3, it can be given by C3 into V3. So it is 200 microfarad and V3 is 85.7. Or it can be written in fraction, whatever you wish. So it will be in coulomb. This is left as an exercise for you. I am just trying to convince you the method or the way to approach such numericals. Right? Similarly, C12 is given, V12 is given. So Q12 can be easily calculated. Q12 would be equal to C12 multiplied by V12. It will be equal to 50 microfarad and V12 it is equal to 85.7. So this much coulomb. Let it consider to be X. Let us consider to be X. I know you can solve it easily. Right? Let us consider to be X. Now look, C12, it is a series grouping of C1 and C2. And in series, the charge is constant. What we have considered is, if Q12 is X coulomb, then C1 and C2 should also possess the same charge, they being connected in series. So what about Q1? It will be also equal to X coulomb. What about Q2? It will be also equal to X coulomb. Now, Q1 is known to us, C1 is known to us. V1 can be easily calculated. Similarly, Q2 is known to us, C2 is known to us. V2 can be easily calculated. V2 would be equal to Q2 by C2. V1 would be equal to Q1 by C1. So knowing the value of Q1 and C1 is given, you can easily find out the value of V1, V2. Right? So all the 8 answers can be easily determined. I hope students, you must appreciate the method which we have done this question. Right? You need to practice such numericals. As much numericals as possible. Then only you will gain in confidence. Believe me, these questions are very simple. Just your approach should be correct. Your approach should be correct. Don't leave any question in the midway. Do solve it. Do all the calculations. The only point to be noted is that approach solving such questions step by step. First, net capacitance is to be found, and then reverse step is to be followed, and making use of the concept that in series charge is constant, in parallel grouping potential difference is constant, and the master formula is Q equals to CV. Out of these 3, if 2 are given, then the third one can be easily solved. Right? And also in series, the formula reciprocal, 1 by C net is equal to 1 by C1 plus 1 by C2. And in parallel, C net it's given by C1 plus C2. So students, I hope this session must be very, very useful to you. And please keep practicing numericals. So we will continue in the next session.